areas that they have hoodlums who come to vandalize such pipelines. I don't know. Most of us must have heard about vandalizations of pipeline by some hoodlums or some touts. So if we can implement IoT to solve such kind of problem, we can add some sensors. Let's say flow sensor. I don't know. Have we heard of flow sensor before? Has
Yes.
anybody heard about flow
Like
sensor?
pressure sensor.
Okay, flow sensor.
Yes.
Yeah. Okay. Flow
I think
pressure
I've heard of
sensor.
it.
Exactly. Yeah. So flow sensor we use where you see flow sensors very well surface in the cheapest places in fuel stations where you go to buy fuel. The place you go to buy fuel, they use flow sensors. That's how you see those readings showing and giving you the amount of liters of fuel or diesel or kerosene you have that's dispensed. So those flow sensors now, once we attach it to those pipe now, we connect it to a particular node where it will be sending the data to a cloud. Then we as the administrators or engineers, we just stay in our office and be monitoring the flow rate of crude oil that is flowing from, let's say, Port Harcourt to Kaduna. You understand? On each particular location is giving us a GPS address or GPS address, longitude and latitude of where that flow sensor is connected. So you know that maybe on a normal, the flow rate of the liquid is flowing at, let's say, 30 liters per hour. And all of a sudden, you are seeing 15 liters per hour. You understand? Then you know that something is wrong somewhere. You send your engineers to that particular region where that flow sensor is giving you that readings for, so that they can go and check and see what is happening. Rather than the traditional idea where they observe that the flow of the oil is not moving well, then they will send engineers to go and survey the pipe that is running from Port Harcourt to Kaduna. They use their vehicles to start moving, monitoring everything, surveying everything point by point. That is very stressful. So if some of these companies are already implementing such technologies into it, so if we can implement such technology in the industrial side, there are so many ideas we can implement in the industrial side using IoT to do. And it's going to work very well, and it's boom. And it's something that, you know, one thing about ideas is once you just give it out and they buy the idea, you are booming. It's not a one-time payment something. It's a continual payment, because they will actually need you to actually renovate the idea as time goes on. So we can use such idea in the industrial side. For those that are engineers, you can go pitch your idea to them. Then the last one we have, sorry, I'm not sharing my screen with you guys. Let me share the screen. Okay. Okay, can you see my screen now? Can you see the screen?
Yes. Yes.
Okay, the last one we have anti-theft system. Anti-theft system. I would like to have an idea of what we can do with IoT to help reduce amount of theft in the country. Some of us here are engineers. Please, you can bring up ideas, you can share ideas. I've been sharing so many ideas. So.
Well, you can implement burglar alarm. As an
Okay,
electronics engineer, I have
okay,
the idea on how it is constructed and how it can be implemented. Now,
okay,
integrating it with IoT, well, it's another level on its own, because now we'll be talking about frequencies of transmission to different locations. But
okay,
the general traditional one of using for burglar alarm for, let's say, uh, your house,
okay,
it's a kind of sensor. You put it there, and when somebody is trying to break into your house, to sound an alarm, first of all, in that vicinity, to wake you up. Now, the other part, which is the development or the increase in this, should I say, in this model, is how to transfer this information that the burglar alarm system have gotten to your phone
okay,
wherever you are. You understand?
okay.
Wherever you
Yeah,
are, and maybe you have a house because and you've not been there for let's say 6 months, and somebody tried to break in. Maybe you're in Abuja. Somebody tried to break
Yes.
into your house. So I'm
Okay.
just talking about the improvement or the improving on the burglar alarm system, whereby you can get information while you are in Abuja and your house is in Lagos that something is going on and something is wrong. So that is where I believe my kind of idea on anti-theft system, which is burglar alarm, can be put into use and you know developed on using IoT.
Yeah. Okay. Moses said he wants to share something. Moses, can you share? Moses Golden, can you share?
All right, can you hear me?
Yes.
Okay, so about the anti-theft system with IoT,
Okay.
from what the other guy has actually said. So, first of all, you can have a system like using PIR sensor to
Okay.
transmit using ESP 8266. So
Okay.
with that, you can actually just get, the proximity when it gets closer. You can send an alarm to whoever. So it's more of like designing the web interface and then designing the hardware itself. So when the hardware senses that stuff, it sends a notification to the cloud that the user actually
Okay.
receives. And then the secondly, which is the one I'm currently working on anyway, is the facial recognition using
Okay.
ESP 32 cam. So it
Okay.
gives the person's yes, it gives the person's um, facial recognition, and then does whatever. If the person has been registered, it now
Yeah.
allows the person to do whatever he wants to do. But if the person is not registered, it sends a
Yeah.
notification to the owner via a mobile app or a web application. So these are like the
Okay.
two ideas I have to share on the anti-theft system.
Okay.
Thank you.
Okay. The last person. Let's any other person that wants to share something that is abstract from that, but is still related to the anti-theft system using IoT to solve it.
Um, if you observe this recent CCTV camera, you will still see that it has this sensor, motion. They call it motion sensor. If
Okay.
anybody passes, immediately it
Yes.
captures.
The
It takes
image.
a snapshot and sends it
Yes.
via SMS to the
Yeah.
owner of the
Yeah.
apartment. So I think IoT is applied in most of for this our
For
surveillance
this.
camera.
Yes. 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 Thank you, Jeremiah, for that. Thank you so much. Actually, we all tried, and these are what we said are actually what's happening now, like real-time projects. Some of the traffic, solar street lights we are seeing here, they have this motion sensor where you pass and it brightens up. Apart from the fact that the solar street light is used to illuminate an environment, it's also good for see that anti-theft system, so that you know that let's say at midnight, 1 a.m., and you just see the light just automatically, the intensity increases. You know that maybe something passed or there is a motion going on somewhere. And some of these cameras we have, they have they have some of these motion sensors where once you set it, if someone passes there, it's going to send an email to you, an SMS that so person passed. If it's sending you an email, it's going to send a picture of the person. So we can actually use this to we can implement IoT in some of these projects. We can make this project to be in real time. We don't need to wait for China to come and actually make it. I believe many of us here are Africans, so we can actually make this project. I'm an embedded system engineer. So many of us here are engineers here. So we can work together to actually create such systems and put it in the commercial market. Then, boom, we've made it. We'll be competing with Bill Gates. Hello? Hello, all. Can you all hear me?
Go
Yes,
on,
we
go
can
on.
hear you.
Okay.
Yes, we
So
can
the
hear
next
you.
slide, yeah, the next slide we're having is IoT key building blocks. So there are some things that are actually recommended for us to make an IoT system or to build an IoT system. And the first we are having smart things. You can see smart things here. And some of these smart things involve those cameras we talked about, cars. Most of our cars are smart cars because we have this OBD2 interface. I don't know whether any of us have heard about OBD2 interface, onboard diagnostics. Has anybody heard about that? It's in most cars now.
Yes, the Muscas.
Yeah, you've heard about Joshua. You have heard about OBD2, right?
Yes, I have.
Yes. So with that OBD2, please quote me if I'm wrong, but I know with OBD2 you can correct the data going on in the car, right?
You can use it to check. Yes, you can check the data on the car on what is faulty, and yes, you can also correct some data in the car. They use it to clear information. Yes, you can use to clear information from the car as well.
Yes, very good. Thank you so much. So
Yep.
many smart things we can connect together. Together, these are like a block of category in the IoT. Smart things, having those objects, those devices, those hardware. Because IoT in engineering side, you're working with hardware and you're also working with software. So having those hardware stable to collect this data, to send this hardware should be able to send data. It must not send it to the internet. So it should just be able to send data to another device. Once this hardware is set, you know that you already achieved one step in work. IoT is Internet of Things, and Internet is a wide area network. It's a very big network. So there are some gateways which we will use to actually publicize our information that we are getting from those smart devices to the internet. And some of these gateways are we have Bluetooth. Most of us are used to Bluetooth. We have NFC. We have RF, radio frequencies. We have Wi-Fi, Wi-Fi networks that are already internet enabled. So with these gateways now, they collect this information and help to transmit it online. So you see that in the IoT key building block, there are a lot of things that comes together that make up that make up the system called IoT device, not just the hardware device itself. So the third block we are having is middleware. This middleware can be a database, can be a cloud server, can be so many things. But most of these middleware are actually cloud computing services or database, cloud database and the rest. It does this with cloud. So when this Wi-Fi or Bluetooth collect this information from the smart device, they are able to transmit it on cloud. So in that way, once it's on cloud, you can be able to pick this information from anywhere you are, as far as you are internet enabled and you have access to pick from those devices. Then the last one is application. Some of these application, we call it API, application programming interface. Some of these interfaces are like your phone, what you see on your phone. We have YouTube. Someone can be, just like we are using Google Meet now for this meeting now. I'm in my end. I'm using my phone, which is the smart things, to transmit this information we are having here using a Wi-Fi internet. Then this Wi-Fi internet is sending this my coverage to Google. Then from Google Cloud, you are able to use Google Meet to actually collect this information and see me and communicate with me. And you can see the arrows are going to and fro. The green and yellow arrows are going to and fro, which means that everything communicates together. Device or an IoT system. I hope we understand what I just said now. Hello?
Yes, yeah, yeah.
Yes.
All right, thank you. So we'll go into the next topic. For those that are just coming now, let me show you the four things we're discussing about. We're discussing about IoT, talking about artificial intelligence, we're discussing about cloud computing, we're discussing about networking. So we'll have to be very, very fast. We're already about 40 minutes going for this meeting. So let's go to AI. And some of these technologies we are talking about, they are interrelated in one way or the other. They are interrelated. But we are using these technologies for our engineering disciplines. So let's go to AI. Artificial intelligence is the application of machine and deep learning in software at the device level. Software can be programmed to provide predictive and reactive intelligence based on the data that is collected and analyzed. So I just need one person to just tell me what they think when they hear AI. What's the first thing that just comes into your mind when you hear AI? Just one person, so we can be very fast. Hello? Is there anybody that has any? Okay.
Yeah, I believe AI is an autonomous system that has the ability to gather data, process it, and make intelligent decisions on its own. Smart decisions.
Thank you so much. That is just the meaning of AI. That's just the meaning of AI. AI is a system where it doesn't need you to actually tell it that this is what this thing means. It's going to be able to make that decision by itself, based on how you trained it, based on how you taught it. This is a revolution of engineering. This is a revolution of technology in this our century here, where you see machines being able to make decisions. Every time you like listening to a hip-hop song, you like listening to this hip-hop song, then all of a sudden, you start seeing your music player suggesting that song for you to always play, suggesting that artist for you to always play. That's AI working at that moment. You understand? The Google Assistant, sometimes you train it so that it can understand your language, your intonation, the way you speak, the way you talk, because everyone has their own accent. The way Ghana speaks their English is different. The way Nigerians speak their English is different from the way someone from US speaks English. So some of these voice assistant features, they tell you, or you see a feature where they tell you that you should train them. They will tell you to repeat a particular word. Maybe my name is Martin. They'll say Martin is a boy. You say it for 3 times. Once you say it for 3 times, it will be able to recognize your voice. So you can say that you're actually teaching it. It's a deep learning something. It's a deep learning something. AI, for most engineers, will be like AI is just if and else. It's about if and else. If this thing is not like this, you should do this thing. If this one is not like that, you should do that. Yes, those are the basic of AI. If and else. If it's not this, do this. But along the line, AI is actually growing, because sometimes those if and else will not be able to give you a very good result. The accuracy of the result might not be too good. But once the machine can be able to study the environment, can be able to study this system and make decision on its own, you see that it becomes more accurate. Let's use, for example, we are having let's say, okay, let's talk about AI in the health system now. Someone's heartbeat is let's say 63 beats per minute every 3 minutes. Then all of a sudden you will start having random heartbeat rates. Maybe it just goes up to 112 beats per minute, and it goes down to 10 beats per minute. And as engineers, you'll be like, if it is greater than 63 beats per minute, you should send message to the doctor using IoT. Send message to the doctor. Doctor, this patient is having a heartbeat of 63 beats per minute. Let us go and check it. You understand? Then you just notice that from that 63, it moves to 120. Then within some seconds, it goes back to 63. Within some seconds, it goes back to, you see that the doctor will start having so many notifications, and he will be confused. He will be confused, like, what is happening? He will be confused. So in that situation, you see that if and else cannot actually give us a good result or an accurate result for that. So we can tell the machine to get an average readings for the next 20 minutes. You understand? It gets the average readings of all the heartbeats of that patient. Then once it gets the average reading, it will say, this is the, what are they calling it? Assumed reading or approximated heartbeat rate of this patient. In that way, you notice that there will be a very high tendency of efficiency in that result that is being sent to the doctor, instead of doctors having so many notifications, because the if and else cannot be able to provide that. So if you check in our slide, we are seeing implementation of AI in real time. And you see that in manufacturing and industrial settings, pairing embedded AI and Internet of Things can result in predictive maintenance for equipment, increased operational efficiency, improved product and service, enhanced risk management. Of course, the application of embedded AI and IoT devices and other settings abound, with implications in security, monitoring systems, smart homes, scientific research, healthcare, to name a few. So I just discussed about the healthcare sector of implementing AI on it. So we have other features in security, monitoring systems, smart homes. We talked about IoT before, and we said, okay, this is what we can do with IoT now. To make our device more smart, more intelligent, we need to implement AI. We need to make our device to be able to understand our environment, to be able to know what we like and what we don't like, so that we can have a good environment and make work easier for everyone. So, do anybody has any question about AI or any contribution? Let's talk about contribution about AI. AI in smart homes, in monitoring systems, in security, and a lot. Anyone? Okay, I believe there is nobody. So let's go to the next slide. We have cloud computing. All this I'm listing, we talked about AI. They are still under IoT. They are still like a subcategory under IoT. So for those that are hearing about cloud computing since cloud computing can be simply defined as the delivery of computing services, including server, storage, database, network, software analytics, and intelligence over the internet to offer faster innovation, flexible resources, and economies of scale. Right now, people don't actually need to use a flash drive or hard disk to go and print something or to collect something. They don't need to travel with their devices, their laptops, their desktops because they need this document. So all those things are already in the cloud there. You understand? And cloud computing is just not just about storage. It's about also analysis. You can implement AI in cloud computing where you collect data. Once you are collecting the data, it's uploading on the cloud. It will be able to make analysis on that data. That's the part of cloud computing. You can see that in the definition, they said it includes both database, networking, software, analysis, and intelligence. This shows that we can implement AI in our cloud. Our cloud is far beyond storage. Many people, when you tell them cloud, they think that it's storing their this thing online. Then when they go another place, they go and get it. Cloud is far beyond storing of data or informations online. We can actually use cloud to do analysis. Just like the first idea I told you guys about a car company, where we'll go to the car company and we'll tell them we want to be collecting the data of those cars and be sending it to a cloud. Then from that cloud, we'll be able to make decision whether this car is good or it's not good. So we can implement an AI inside that cloud system where we can be able to do such kind of thing. There are some terminologies they use in clouding computing, which some of us must have been aware of it. We have IaaS, we have SaaS, and we have PaaS. IaaS means infrastructure as a service. We have platform as a service, and we have, I think, system as a service. These are different features or types of cloud computing. But we won't discuss that now, sir, because those are not really important. But as an engineer, how do you think we can use this cloud? We can actually implement this cloud in our day-to-day activities, in our systems, where those of us working in the industry, we're having so many places we're working at, we can integrate a device that sends information or data about a particular sensor or a particular node to a cloud. Then that cloud, we can implement AI in that cloud, so that the cloud will be able to analyze such data and be like, okay, tell you the engineer, so stuff or this particular stuff is having issue, or this particular stuff is not having issue. So this is the power of cloud computing. All this works with AI, IoT too, Internet of Things. It's what make up an Internet of Things system, cloud. Then some of the cloud computing services we have Amazon Web Service, we have Microsoft Azure, we have Google Cloud Platform, TeamSpeak, Arduino IoT Cloud. For those of us that are working with Arduino, Arduino has the IoT Cloud where you can interface their devices to the cloud and actually collect this device to make further analysis and the rest. We have TeamSpeak. These are open source cloud-based, IoT cloud-based platform. So you can put your project, connect it, and send it to be sending data to TeamSpeak. And automatically, you see, it creates this graphical picture of the data that is being sent. It creates this graphical picture, which will be used to make analysis. Rather than the data just storing in the cloud, then you go there and start making analysis on that data. As it's going there, analysis is being made. AI is already implemented there. So, but the top-notch cloud computing service we have Amazon Web Service. Some of us testified about Amazon Web Service. I don't know if there's anyone enlightened a bit about Amazon Web Service. You just give us just a minute to talk about Amazon Web Service. I don't know. If anyone has much idea about Amazon Web Service? Hello?
No idea.
Okay. Okay, no idea. Okay. So Amazon Web Service is a cloud platform where you collect data and it makes analysis of your data. It does a lot of analysis to give you a good result about something. So let me just check. So I'm coming. So from my notes, Amazon Web Service is a secured cloud service platform offering computing power, database storage, content delivery, and other functionality to help business scale to grow. It also stores our files on the cloud. So this means that, let's use for example, let me just explain what this means, because Amazon Web Service, Microsoft Azure, Google Cloud Platform, they are all interrelated in one way or the other. Let's have an attendance system. We have an attendance system, right? And this attendance system, you use your fingerprint or RFID card to take attendance. And once it takes the attendance, it sends it to a cloud platform, let's say Google, to your Gmail account on spreadsheet. Now, once you receive the information, it also makes analysis on maybe that is your company. Let's assume that place is your company. It makes analysis and said, okay, so person did not come to work on Monday and Tuesday. It's going to deduct this particular amount of money. Then at the end of the month, that same cloud that it's sending is going to send you an email that Mr. Martins, you have to pay your employee for this month the sum of 70,000 naira. Then you'll be like, why am I paying my employee the sum of 70,000 naira? I thought I'm supposed to pay 150,000 naira. Then you check the track record. You see that the employee did not come. The employee did not come to work on this day. The employee did not come to work on that day. The employee did not come to work on that. So it's already deducting the amount of money automatically. And there's a device, the hardware device is already at the gate where they come to take this attendance. And everything is being done. You're not stressing yourself to actually come and check, cross-check the attendance and the rest. So Amazon Web Service can help to make this thing come into existence. So this is the power of a cloud-based computing service. So you can also do these things with other open source cloud computing services, like TeamSpeak, Arduino IoT Cloud. We have one called IFTT. If this, then that. Those are open source and cloud computing service. So I hope we understand what I just said now.
Yes.
Yes.
Okay, thank you so much. I hope, thank you. Yes. So let's go to the other one. Careers in cloud computing. You know, as we are discussing about this technology, we also discussed about the the financial side of it. How are you going to be successful? Cloud computer engineers or cloud administrators are sought after. Like they are very sought after because you don't actually need to go to the company to work. You can stay anywhere you are to work as a cloud engineer, as a cloud administrator. And as of August 2020, our cloud administrators, they are being paid an annual sum of $82,000 per year. And the lowest of 10% of workers are earning an average annual salary of $50,000 per year. And the highest are earning annual salaries of above $130,000 per year. These are not figures. These are real things. I'm not a cloud engineer. I wish I'm a cloud engineer. That's not my specialty. So maybe very soon you won't be surprised when I start learning about cloud. So cloud engineers or cloud administrators are sought after persons. Big platforms like Google are looking for cloud administrators. Amazon, Facebook, they need cloud engineers that should be working for them because everything in their database, if anything is tampered, they will lose a lot of things. So they look for cloud engineers, data scientists, IT administrators. You can see the careers we're having for that. We have cloud engineers, data scientists. We have so many careers in cloud computing, which you can go and learn. And some of these online courses, we have Amazon Web Service certified course. We have Microsoft Azure. You just Google about this stuff I talked about, so that if you're interested to trade, you can register for that, and you learn it, and you become a sought after person. You become a very resourceful person. So that is that for that. Now the last and maybe the least of our discussion for today. I think I'm very, very fast. Am I very fast or slow?
No. It's okay.
It's okay. All right. Thank you so much. So, networking. Networking is another trending technology in our engineering sector. Networking. And from our definition here, networking is also known as a computer networking. It's the practice of transporting and exchanging data between nodes over a shared medium in an information system. Networking comprises not only the design, construction, and use of a network, but also the management, maintenance, operation of the network, infrastructure, softwares, and policies. Networking facilitates everything from telephones to text messages and to streaming of videos to the Internet of Things. If you observe, everything I discussed about is still going back to the number one thing we talked about today called Internet of Things, right?
Yes.
Yeah. So it's still going back to that IoT. Now, networking is just a very simple thing, which means like we are devices or persons connected together, and they are able to transmit informations between each other. You get between each other. They are able to transmit information. Some of us are using mobile broadband communications network like MTN, Airtel, what are they calling them again? 9Mobile, and so many of them. So these are telecommunication networking companies that work together, and they can be able to communicate with you because all the devices are connected to a particular common ground, which they'll be able to exchange ideas and the rest. But beyond networking, as an engineer, what does networking profit to you? What's the benefit of networking to you? As an engineer, you can design and construct and use your own network. For example, let's say, how many of us we know this embedded device called ESP32? Some of us have talked about it here. Node MCU.
Yeah, I've heard it. I've heard of it.
Okay. So yeah. So some of these devices now, we can actually make let's say let's work with the first example I talked about in the cloud computing called attendance system, right? Now let's assume we use let us assume we use this networking idea, the implementation of this networking to our embedded device called attendance system. We use ESP32 or ESP8266 to make this device, and we sell to companies, and companies buy it. And remember, the device is already connected to cloud. Once it has internet access, it can connect to cloud and be sending the attendance system on cloud. And the cloud, you will set up the cloud with AI features so that it can analyze the attendance and draft out the payroll salaries for each staff. What about a situation where there is a bug? No machine is 100% efficient. No matter the amount of experienced engineers or experienced programmers that produce 100% accurate. So there is always time when there will be upgrade. And remember, this ESP32 and can you all hear me, please? I think there's a network glitch I'm having.
Yeah, we can
Yes,
hear you.
yes.
Okay, sorry. And this ESP32 and ESP8266 and other embedded devices, we use it to make this thing. And there is a bug. Remember that if there is a bug in your Arduino code or your microcontroller processor, anything you are programming which involves hardware, if it's you that do it by yourself, maybe DIY, you do it yourself, you need to access that device to actually update the code. Am I right?
Correct.
Yes.
Oh, yeah. But there's a feature we call OTA. OTA means over the air. Have we heard about that feature? Over the air.
Yeah.
I've not heard of it before.
Yes.
I've heard of it before.
Okay, over the air is what, over the air or on the air is what we use in our satellite broadcasting television like DSTV, GoTV. Sometimes you see your GoTV doing upgrade or DSTV doing upgrade automatically, and you'll be like, this thing is not connected to internet. How does it update automatically? So it's because there is this OTA feature in it. And that feature is comprises of some hardware that are inside the decoder, which makes the manufacturer having access to that device, even though they have sold it to you, you've bought the DSTV, they can still update it. So if we create an attendance system now that is using fingerprints, and because of COVID-19 guideline, we decide that, okay, nobody should be using that fingerprint again, so that to avoid contacting coronavirus. So we should be using RFID card now. And they now ask you as the engineer that, please, we want you to upgrade this device to be using, what are they calling it? RFID, not just fingerprint. If it's what we did by ourselves, the first thing that will come to our mind is to go to that company that we installed that attendance to actually fix that feature by it. But with the help of OTA, we don't actually need to go there, because this seminar or webinar we're having here is actually also to make us entrepreneurs as engineers, techpreneur people. Imagine we supplying this device to over 1,000 companies, this attendance device. So we'll now start traveling around to collect our device to do updates. We don't actually need that. We can actually do the updates over the air by using that feature. And this is where networking comes into play. All the devices are networked together. So even the ones that are still in the storeroom that they have not supplied, once they put on that device, it will automatically connect to your network as the manufacturer of that device, so that you can be able to access it, to do updates on it, to upgrade it, so that it can fit in with the current standard at that period. Because if you make the device 2020 and maybe it's still in the warehouse and they haven't used it, maybe 2023 or 2024, a customer now buys that your device. You know that there are some updates you have done for 2021, 2022 that will still be on the air waiting for that device to come on. Once it comes on, it automatically updates and it connects to your network. This is the power of networking. This is the power of networking. So in summary, networking as engineers, careers that are available for networkers or people. We have network administrators, we have network support engineers, we have network support technicians, we have IT administrators. Like here in Nigeria, I think the average salary for a network support engineer or administrator is uh, about 2 million naira for network support. So it's kind of um, okay, an average salary. We're not talking about when you now have up to like 5 years experience in it. You won't be earning that. You'll be earning more than that. So if you want to learn networking, you can actually apply for certification courses with Cisco. We have CCNA, CCNE, and so many of such kind of courses. If you want them, you can actually contact us so we can help you with that. I hope we understand.
Sure, we do.
No?
Yes.
Yes.
Yeah. So so now we'll be entering into the question and answer section. So do anybody has contribution or questions and answer that they would like us to um, that they would like to contribute or talk about?
I have a question. Can I go on?
Okay. Yeah, you can go on.
Okay. About the over the air, how does it work? And can you really break it down? I'm so intrigued
Okay,
about.
over the air.
Notice my Go TV does that a lot. I saw there's no internet,
Okay,
and I
you're good.
wonder how.
Oh, don't worry. I'll come to that. I'll come to that because after this question and answer side, there's something I will want us to actually talk about. So I will pin your chat. Then any other contribution? Hello. We're not having a lecture now. This is like we're
Not
having
from.
Hello, we are
a
here.
discussion. Okay. Okay. No problem. Okay. Let me do this thing. Let me share my screen. I want to share my screen. I want to show you guys something. Okay. Let me just share the screen from my phone. Can you all see my screen?
Yes,
Yeah, we
we
can.
can.
Hello?
I think I can see. Yes, I can see
Okay.
your screen.
I can see your
Okay.
screen.
Okay. All right. Um, I wanted to show. Please, so sorry for the inconvenience. Because I was having a glitch with my system. Okay, can you see this now?
Yes, I can see.
Hello?
Yeah, I
Okay.
can see.
Uh, okay. You can see that in the screen now we're having some business ideas in engineering networking, right?
Yeah.
Yes.
We can see private ISP and we can see embedded system devices. So that embedded system devices, let me start with that one. That is where I talked about the this thing OTA, where you can implement OTA networking feature in your embedded system device. I will still come to your question, Joshua, but let me start with the private ISP. Do you know that you can actually sell internet to people, to your customers? For example, let's say you are partnering with one big telecom giant like MTN, and they're supplying you up to 5 terabytes of data. You know what's 5 terabytes of data? That should be how much? 5,000
That's yes,
gig, right?
yes, 5,000 gig.
It's possible. Yeah. It's not a laughing joke. It's possible. 5,000 gig is something that we know that even you alone you cannot finish such kind of data, right? Now you can
Yes.
sell this data to people around your neighborhood without you actually what are they calling it? Using Wi-Fi, normal Wi-Fi, this thing, because Wi-Fi has a short range now,
True.
Abi.
Yes.
And without you
Yes.
also collecting all the without you also collecting their numbers to share, you can be selling data to people. How do you do this?
How do you
Most
do
of us
that?
have heard of what we call Wi-Fi. Yes, that's what I'm coming into now. We have heard of what we call Wi-Fi stations. Wi-Fi station is a situation where you come to your house and you check you on your Wi-Fi of your phone and you are seeing a particular Wi-Fi network. Once you connect to that Wi-Fi network, it asks for your username and password. You put in a username and password. Automatically, you start browsing. We call that hotspot login. Hotspot login feature. That's just a very technical name. But we have seen such features. If you go to cybercaf, where they use internet, you see such features. You connect to the Wi-Fi and you request for username and password. Once you put the username and password, you start browsing, right?
Yeah.
Yes, right.
So
Yeah.
there's what we call point-to-point networking, point-to-point or point-to-multi-point. Point-to-point and point-to-multi-point is what we use even in our day-to-day internet. You see all these telecom masts you see on the road, you see them on the streets. There are so many antennas you see on that mast, and those antennas are facing different directions. Now, when those antennas are facing different direction, you go to places like bank. You see bank having one big mast or one particular antenna that is pointing to one particular direction. As it's pointing to that direction, it's pointing to a particular mast. As it's pointing to that mast, it's receiving internet data automatically. It's receiving internet data. Once it starts receiving internet data, you can rebroadcast that data within that building using a normal router. We have come across routers before. I've heard of routers before.
Yes.
Yes, I've heard about that.
Yes.
Yeah. So it starts the router helps to rebroadcast an internet data wirelessly or through LAN cable. So with this idea now, what it means is that if you have a very big amount of data which you know that you cannot finish, I'm talking about data of up to 5 terabytes, 10 terabytes of data, you can actually go partner with some of all these people that have these big towers and big masts. You come there, you mount your antenna. Once you mount that antenna, there's a particular name we call it, I think it's called access point or so. Once you mount that access point or on that tower, then within that area, as most access points has a range of up to 30 kilometers. I know 30 kilometers is a very wide distance. It's a very big distance. So with that idea now, you just go to people's house and mount your antenna. Once you mount the antenna there, for people that will be using your data, then they'll be paying you monthly. Then they're using the data. So you can do that in your state, you can do that in your community, you can do that in your country. So that's for the point-to-point side. Then the other type of business idea we have is satellite networking. Satellite, as of recent, Elon Musk. Do we know Elon Musk, the owner of Tesla?
Yes. Yeah. I know. We know him.
Yes,
Yeah.
Yeah.
There's no engineer that would not have not heard about Elon Musk. Elon Musk partner with Google Cloud to create a good satellite infrastructure. Let me just explain what this thing entails. This thing entails that we will now reach a situation where, as you are using your Go TV or your DSTV at home, some of those DSTV they have internet ports on the back. You can connect that internet port to your system, and your system will start browsing without you buying data. That is what it means. You just use satellite to collect data And rain cannot stop it. Like if it's raining, the data transmission will still be good and it's unlimited. Maybe what you'll be doing is to pay for the speed, and it will be far cheaper than what you use for your normal telecom giants like MTN, Glo, and the rest. So this is the technology that is coming. Before 2025, we'll start using that. So what you just do is that you don't need to buy satellite, or your existing satellite already, like DSTV, GoTV, and the rest, strong CAN and the rest. You can use them to actually put internet in your house. So if you can do that in your house, then you can do business with it. You can supply the network to your neighbors, and they will be paying you money monthly. Is that not a good idea?
It's a very good idea.
Data is something that we use every day. Yes, data is something we use every day. It's the people go to say they don't get money for data, but they see themselves they bring money for data to buy data.
So
Are you saying it?
Na
So data is
addiction.
yes, it's not be addiction something. It's the trend in technology. It's just like you using phone. When God created you, God did not give you phone, or when you were created, you were not coming out of your mother's womb with phone. But you cannot do without your phone. It's part of your life now. So that's how data is. So you can actually, in this period, you can actually sell this data to people, your neighbors, and they pay you money, and you just stay at home and be making money. Don't need to start skilling yourself, looking for a job and the rest. So back to what Joshua said about embedded system device. Joshua, now you now believe that with satellite dish now, there are some forms of internet data that are connected, right? And those internet data is what it sends to that OTA device inside the GoTV or DSTV that makes it prompt that upgrade or update it's doing.
I believe that now, sir. I do.
Yes. Thank you for believing that. So that's just it. So I think we've come to the end of this section, but before we actually close officially, I'll just tell you some of the products that my company do or they give out. So you can see, can you see this slide?
Yeah.
Yes.
So you can see that we're having get unlimited internet access, right? And this unlimited internet access we talked about is actually unlimited internet access. So if you're in Lagos State, if you're in Abia State, if you're in Onitsha, I think those are the three places that our branches are. We're still building in other states like Asaba and the rest. If you're in some of those states in Nigeria, we give unlimited internet access at this rate. Our lowest internet access is 3 megabytes per second for 10,000 naira only. So imagine you browsing, downloading, streaming whatever you want to stream and browse whatever you want to browse at the cost of 10,000 naira for 3 megabytes per second. 3 megabytes per second. Some of our telecom giants, some areas that you stay, you can't have up to that internet speed. I don't know. You can't have up to that internet speed. But that is the lowest internet speed we give out for 10,000 naira. We have other internet speed you can see on the flyer. We also have the highest one we give is 20 megabytes per second for how much is that? 420,000 naira, which is about 200 and something dollars. Let's say $220 or $230. It's still cheap for 20 megabytes per second. 20 megabytes per second is just on the go. Like you'll be streaming something, you think that you are watching it. There's no crack, there's no lagging in the network. Everything is just very fast. So if you're actually interested to use any of this our data plan, you can reach out to us at IGHub Africa. You can Google about IGHub Africa on Google. Our contacts are there, our emails are there. You just connect with us and we come to you and deliver this service to you. It's tested and trusted. So it's not something I will start hyping over again. So I'm coming. They will also have another product. We have embedded system training. Some of us here are engineers. So this might be good for us because as an embedded system engineer, I am an embedded system engineer. We work with IoT, we work with AI, we work with cloud computing, we work with networking and other technologies too. So embedded system engineering it's what is trending. Some people call it mechatronics. Uh, you can call it mechatronics, but embedded system it's very broad. Mechatronics is part of embedded system. It's a subcategory. Just like embedded system is a subcategory under electrical electronics and computing. So we do training. We have beginner, intermediate, and advanced. So for the beginner, we train you on the basic electronic practical, like you're just going to be very grounded in electronics. We train you on Arduino programming. This Arduino programming is beyond making a light blink because some of us will think Arduino is as simple as ABC, but Arduino is actually as simple as you think. When you advance into Arduino, you see yourself becoming a C and C++ programmer. So we also have robotics. We train them on robotics, circuit design and simulation. This is for the beginner side of this training, for the beginner side. So imagine as a beginner doing all these things. What about the intermediate and advanced? We have in the intermediate electronics troubleshooting. We teach you how to repair any kind of electronic device, introduction to Internet of Things, you implementing Internet of Things technology in anything you are doing because this is the trending technology. Installation of smart device, those CCTV cameras, those smart CCTV cameras that someone talked about, we also train them on how to build this device and actually install them. Inverter systems, you learn how to build inverter yourself. You learn how to install inverters yourself. And many other engineering projects for the intermediates, we do that. For the advanced, we have automated control system, maintenance of equipment, networking, engineering management. So for this advanced, it's like learning everything, both beginner, intermediate. But for you to do advanced, there are some requirements, some exams you write so that not really exam, theoretical exam, practical exam. So I will be very sure that this person is grounded in the electronics something for you to do training in our advanced. So you can start with beginner, you can start with intermediate. Then the last, IGHub, my company, will offer workspace to people. Can you see my screen?
Yes.
Yes.
This is how our company is.
Very
Yeah,
sure.
this is how my company is.
That's it.
So if you're in Onitsha, you can come to Onitsha. You can see the address at Onitsha. You can see the address at Aba. Right now, I'm in Aba now, having this webinar with you all. So you can come and register for our workspace. We give internet, high-speed internet, just as I told you. We are already an internet service provider. We give constant power and so many features. So you just Google IGHub on internet on your Google and you see many of our features there. So you come and be relaxed. Our workspace is good. It's a very good environment. So it's not something that there is noise disturbing you or anything. 24 hours light, internet space secured, high-speed internet. You can do your online exam. You can come to our company to do your online exam. So you won't be interrupted by any kind of internet something. We are service providers. So thank you all once more for joining for this meeting. Hello,
Please,
can you hear me?
hello. Yeah. You said the name of the company is IGHub dot
Yeah, Innovation Growth Hub.
website. The website. IGHub.
Okay, IGHub Africa, ighub.com.ng, ighub.com.ng.
.com.ng. Okay.
Yeah, yes.
Okay,
Have you seen
I'm
it?
in Ghana. I'm not in Nigeria. I'm a Ghana.